Good morning, guys. Okay, I hope you understood the live class which we took yesterday. Yesterday was the last class, I don't remember because I'm recording the video. Okay, so dimensional analysis we will take later on now, guys. So today we will be doing the continuation of the previous section. We will talk a little bit about what errors are that, and we learned what is absolute error, which is what is mean, absolute mean error, then relative error and percentage error. I hope you are registered or you have registered those terms in your mind, because now we are going in calculation section, guys. It's a very important section of the chapter. Now we have entered into the game properly. Right, so till now we have actually dealt with only small sections. That's why you would have felt as very easy. Now the game is on. So let's move on. So the first or the topic which we are going to take, which I have written in the introduction itself, propagation of errors. Now what do you mean by propagation of errors? Then the definition wise is, suppose we are having an experiment. We first write down the experiment observations in columns, right? And those written section, that is 2.1, 3.3, which you are measuring, is known as measured value. Now you put this measured value in some equation, and you get a result, right? That value is known as calculated value. Now, what happens if there is an error in measured value? Then that calculated value also having the error. That means the error has propagated. I hope you didn't understand anything. See, I will write a small example. See, you are doing an experiment of, say, let's Ohm's law, right? And you're finding the value of resistance. So you measure the voltage and you measure the current, right? You measure the voltage and you measure the current, and you make a column where you write the values of V by I according to your measurements, right? Those values, that is, it might be 0.3, it might be 0.4, 0.6, etc., right? These values which you are calculated, right, and you written down in the observation table, this is known as measured value, right? So actually, what are the measured value? This is actually your calculation, that is V by I is your calculations. The values which you tabled below V and I, that is your measured value, right? So what happens? The measured value itself is having error. That means this equation where you substituted those values will be having the error, right? So the error in the measured value, after you put it in an equation, the calculated value also has this. It might not be the same error. It might have what increased, right? That type of error, or this type of method here, this is known as propagation of error. So how many type of calculation basic expressions are there? Addition will be there, right? A plus B form, or it can be a minus B form. That is in the expression, or the equations can be additions, or it can be multiplications, or it can be divisions, or it can be subtraction. Only 4. And then there is an exponential function also. So what we are going to take each one of the example. Sorry guys, why I don't know, it is zooming in and zooming out. Is it okay now? Okay, so let's move on. So first we are going to deal with sum. It's actually sum and difference comes in one column, but I want to make it as four sections. So first we are going to, it looks like we are sum. Right, sum means addition. See, so I'm going to introduce some of the terms is quite similar to your textbook, but I'm going to introduce some suffix to it so that it will be easy for you guys to understand. See, I'm measuring two values, A and B. This is my measured value, right? So measured value, I'm going to write it as AM and BM. Measured value means there will be some error, right? So it is not the actual value. There will be some error. So earlier I have told, right, any value, say A, true value, right, is equal to some measured value plus or minus error. It is always like that. If I have not told, just listen guys. Every true value, which is, suppose there is a pen, it is produced by a company, right? So they will be having the exact length of that pen, right? That is its true value. But if I use a scale and measure, right, that becomes a measured value due to some reasons that maybe the measured value might be greater than the true value or less than the true value. That means there is an error, right? So always this, suppose the pen is having let's say is of 3 centimeter length, or let's say 3 centimeters very small now, so let's say 10 centimeter length actual, but I measured it as 9.6 centimeters, so there is an error of plus, right, 0.4 centimeter, right? Sometimes I made a measurement like this, it is 10.4 centimeter, right? I measured it at this 10 centimeter pen as 10.4 centimeter. That means there is an error of 0.4, minus 0.4. So I can say this 10 centimeters lying between what? A measured value plus or minus 0.4. That is, the measured value is either less by 0.4 or greater than by 0.4. Hope this much is clear. So every true value lies between plus or minus its error with the measured value. Okay, measured is something which you measured. 10 is something which is true value, actual value, right? So I'm going to introduce two terms, or let's say an expression is that there is an equation Z is the result is equal to A plus B. That is, suppose I have a rod like this and there is a flag like this, right? And you are asked, this flag say is having a length B, let's take capital B, and this stand as a length A. Now you are asked what is the total length, that is your Z. So Z will be equal to A plus B. I can write it like this, simple. But when A is the actual length of this rod, right? So while I am measuring this A, that can be an error. So measured value of A is AM and measured value of B is PM. B means flag. Now I can write A, which is true value A, is equal to measured value of A plus or minus some error made by me. Let's write that error is delta A, absolute error. Error is usually written as delta A. That is still can change, right? Small value, that's indication delta, right? Now similarly, B is a measured value, right? B is the actual value of this flag, right? So actual value of this flag is the measured value which I did plus or minus the error I made with it. Clear? Right? So similarly, the total length, right? Z is the total actual length, true length. So Z will be having a measured value, which is sum of these two, right? BM plus AM. ZM, which, see, I had a pen or a scale. Suppose A, I took it, it was actually A's true value is 2 meter. I made it as 1.8 meter. If B's actual value is 3 meter, I took it as 2.6 meter, means Z is supposed to be 5 meter. But I get the actual Z as how much? 4.4 meter, right? So Z, this 5 is its true value. So true value, and this is my measured value, is 4.4 plus or plus 0.6. So there is a 0.6 error, right? So similarly, Z, which is a true value, is equal to measured value of the Z plus or minus error which is happening in it. Clear? So you have 3 terms written. So every term can be written in this value. True value is equal to measured value plus or minus its error. This much clear? Now what is the problem here we want to do? If there are 2 terms, what happens to the error when they are added? Clear? So I'm going to add it, guys. So let's say, so Z is equal to A plus B, right? Now here, in place of Z, I'm going to write ZM plus or minus, say this in this equation, okay? Zm plus or minus delta Z is equal to, in place of A, I'm going to write this one. Am plus or minus delta A, right, plus Bm plus or minus delta B. Right, now I'm going to rearrange it, guys. Zm plus or minus delta Z is equal to Am plus Bm plus or minus delta A plus or minus delta B. Just rearranged it. Right, now guys, I just told you these are the measured values, right? So measured value of A, measured value of B, when they add, we get the measured value of Z, that is Zm is equal to Am plus Bm. Right, measured value of Zm is, or measured value 4.4 is the sum of 1.8, 2.6, right? So measured value of Z is equal to measured value of A plus measured value of B. So here in place of Zm, I'm going to write this value, that is Am plus Bm plus or minus delta Z is equal to Am plus Bm plus or minus delta A plus or minus delta B. Now I can cut off these two terms, common terms. So in LHS, there is plus or minus delta Z is equal to plus or minus delta A plus or minus delta B. That means this symbols, this is plus goes off, minus goes off. So I can write Z is equal to delta A plus delta B. Clear? I hope you can understand by doing a problem. See, I'm taking, let's say L1, length of a, see, let's take this example itself. Right, so let L1, that is the length of our post. Let's say it is 2 plus or minus 0.3 meter. That is true, 2 is its measured value, 0.3 is the error in that length. Now L2 is the length of that flag stand, along with the stand. Let's say it is 3 plus or minus 0.5 meter. So 3 is its measured value, 0.5 is the error in that measurement. You are asked what is the total length. That is, you are asked L1 plus L2. Right? How would you do? See, you are told whenever you are having two terms, when you add them, right, when you add them, you are getting only the relation of error, guys. The sum will be what? 2 plus 3, 5 itself, right? But 5 plus or minus some error has to be measured, right? I just told you, when you are adding or subtracting whatsoever, when you add two devices or two terms, you get a value. That value itself might be having an error due to the measurement devices or due to you. So addition, when you are adding, obviously you have to add the measured value, right? So when you are asked what is L1 plus L2, my first part which comes is 2 plus 3, that is 5. But I don't know the error in that measured value, because each length when I measured, I made a small error, right? So by the previous method, or I have just found out that when you add two values, so when you add two measurements, the errors of the result, that is delta Z is the result, right? Error of the result is the sum of the errors of individual measurement. See, L1 is having the individual measurement error of 0.3, L2 is having an individual measurement error of 0.5. So L1 plus L2 will be having the length measured value 2 plus 3, 5, plus or minus error should be added, means what would the answer be? 0.3 plus 0.5, that is 0.8 meter. Clear? It's very simple. You just have to add the measured value, you put it, then you just have to add the error value. Clear? Now you are asked, suppose sometimes they can ask what is the relative error. So this is in the term of Z plus delta Z, right? So how do you write the relative error? Relative error formula is delta Z by Z, right? Absolute error by true value or measured value, whatsoever. So So this is the formula, right? I hope you remember it was delta A by A, right? Or you wrote it as mean and mean, right? So this mean I can just replace, or I can neglect this mean. So delta Z by Z, writing the error by the measured value, right? That is known as relative error. You are relating how much the error is, you are comparing with its actual value, right? So 0.8 is its error, so it is 0.8 divided by 5, or I can write it as 8 by 50. Right, ratio etc. You can, if you want, you can write in decimal also, right? 0.8 it goes 1, then 30, that is 0.16. That is its relative error. In percentage, what happens? You just have to multiply with 100. So if you multiply this 100, it will be 16%. That is its percentage error. Clear? Right. Now we'll go for after sum. It is, the case will be of subtraction. I will take the same example, right? You are having two lengths A and B. What is the difference? That is, what is A minus B? If you subtract this much length from A, what will be the left out portion, right? So subtraction, same terms guys. So write the heading as subtraction. Subtraction, I'm going to write Z. That is a true value of the resultant is equal to A minus B, right? And measured value of Z will be equal to measured value of A minus measured value of B, right? Now Z can be written as, hope you remember, Z plus or minus delta Z, right? Any resultant will be also having or carrying forward the error which has been done in the measured values of A and B. So A can be written as A plus or minus delta A minus B plus or minus delta B, just like the previous case, right? Just like the previous case, I am going to rearrange it guys. So Z plus or minus delta Z equal to A minus B, this goes over here, plus or minus delta A plus or minus delta B. Right? Now Z is equal to A minus B, right? Plus or minus delta Z is equal to A minus B plus or minus delta A plus or minus delta B. I can cut off A minus B. So I'll write it as delta Z is equal to delta, plus or minus delta A plus or minus delta B. Or it is delta Z is equal to delta A plus delta B. Look guys, you get the same equation in the case of addition also, right? So you can infer one thing. During addition or subtraction, right, when you add two quantities or when you subtract two quantities, error of those quantities is always added. During sum and difference, error is always added. We'll do a small problem. This is the same problem as it was mentioned in your textbook guys. So you're given two temperature. I'm doing a problem along with it so that you guys can understand the logic. That's why I'm doing a problem along with it guys. See, that is T1 is the temperature. You are given 20 degrees Celsius plus or minus 0.5 degrees Celsius. And similarly T2, the second temperature is 50 degrees Celsius plus or minus 0.5 degrees Celsius. And you are asked what is T2 minus T1. Right, that means you just have to subtract, right? So easily you can find the measured value, which is 50 minus 20, that is 30 degrees Celsius. Right, now what is the error in calculation here? That is a problem, right? So I just told you during the difference also the error is always added. So what is 0.5 plus 0.5? It is 1, right? So 1 degrees Celsius. So the error while you finding the difference is sum, right? That is 20 degrees Celsius, 50 degrees Celsius. The temperature difference is 30 degrees Celsius. But while calculating, I am making an error of 1 degree Celsius. So that the temperature can be either 31 degrees Celsius or it can be 29 degrees Celsius. This much clear? Very easy. Again, if you are asked to write the relative error In this calculation, it is 1 divided by 30. Delta Z by Z. 1 divided by 30. Right? In percentage, it will be multiplied with 100. So it will be 10 by 3 or 3.33 percentage. Clear? Right. Let's move on to the next section. While we completed subtraction, let's do the multiplication part also. I don't know if I can complete division here. As much as possible, we will complete. Okay. So next is multiplication. Just like this one. Next is multiplication of errors or product of errors. Both of them are same. Just like the previous cases, guys, I want to find the value of Z, and it is a product of two terms, that is A and B. Z is equal to A dot B or A into B. So it's just like the previous case, Z can be written as what? Or Zm. The measured value Z is product of measured value of A and measured value of B. Right, so here I can write Z as Z plus or minus delta Z. A can be written as plus or minus delta A into B plus or minus delta B. Right, this much clear. Here there is a little bit extra steps, guys. Please follow how I'm going to do it. Right, now in place of Z I'm going to write it as A into B plus or minus delta Z. So let's bring the or open the bracket, guys. So it will be A into B, right? A into B, then A into delta B plus or minus A into delta B. Then you're bringing this term into this. So it is plus or minus B into delta A. Then there are two deltas, plus or minus delta A, delta B. Right. Now this term delta A plus into delta B is very small, guys. Very small means, see, delta is, let's say it is 0.5. Delta B, let's say, is again 0.5. So what will be delta A, delta B? It will be 0.25. So very small quantity, right? Less than 0.5 itself. So whenever you multiply a very small quantities, when you multiply 2 or 3 quantities, the entire value will be very less. So this much value delta A by into delta B is very less. So I can write here right. So when I neglect this term, now rest of the things, see this A dot B, this A dot B goes off. So there is only delta Z plus or minus, right? Plus or minus A delta B plus B delta A. See, now we are going to introduce an extra step, guys. So let's divide throughout with the term divide throughout by Z. So it will be plus or minus delta Z whole divided by Z. This plus or minus A delta B divided by Z plus B delta A divided by Z. Right. Now in place of Z, you just written earlier, I am going to write it as A, B. Right. So it will be plus or minus A delta B divided by AB plus or minus B delta A divided by AB. Right. I can cut AA here, BB here. So in LHS it is plus or minus delta Z by Z is equal to plus or minus delta B by B plus or minus delta A by A. That means I'm just removing the plus or minus, so it will be delta Z by Z is equal to delta B by B plus delta A by A. So what can you infer from this equation? You can infer that when you're doing a multiplication of two numbers to get a resultant, that resultant's errors relation will be there. You cannot add or multiply the error here in the just like the case of sum and difference. You can add the relative errors. That is the relative error of the product is equal to sum of the relative errors of the factors. Clear? I hope you can understand the logic with the problem. See, you are given length of a rectangle. Let's say it is 5.7 plus or minus 0.1 meter. That's a question, guys. You are given length of the rectangle as this much value. Similarly, the breadth is 2.4 plus or minus 0.2 centimeter. That's just given. Oh, sorry. If this is centimeter, let's say it is in meter. Right? You are asked, you are calculating the area of the rectangle within the error limits. That means you have to find the area and also its error. Right? So I hope you remember the area's equation. It is length into breadth. Right? Now let's say I'm going to write area as A. Right? So the true value of area is length of the rectangle into breadth of the rectangle. Right? Similarly, I hope you can, but you are measuring the area. That means there is an error in here, right? There is an error in length and there is an error in breadth also. So measured area is equal to length measured into breadth measured. Right? This much clear? See, this A, L and B, if you want, you can write it as cap, small letter, and this one is small letter B. It's okay. What's the term? Right? This much clear? So the area, actual area, is equal to measured area plus or minus delta A, where this is the error in the area. Right? So you have to find this AM as well as you have to find this delta A. Right? What is the measured area? That is length measured. How much is the length measured? It is 5.7. So I am going to write this value AM is LM. That is 5.7 meter into BM. That is a measured value of breadth. That is 2.4. You will get around what, 13.68. Just calculate it, guys. I'm not writing it. The calculation you can do by yourself. Right? That is a 13.68 meter square. That is a measured value of area. Clear? So here one section is completed. Now the problem is, what is delta I? That is the error in area calculation. In the case of multiplication, right? In the case of multiplication, there is only one thing which you know, that is the relative error of the product is equal to sum of the relative error of the factors. So if I want to find delta A, right? Delta A by A. That is the relative error of what? Your area is equal to, or in place of A you have to write measure, right? So it is AM. So delta A by AM is equal to delta B by BM plus delta, sorry, I wrote it as wrong now, delta, it's okay, divided by this breadth, this is for length, right? Clear? Now what is delta B? That is the error in breadth. Okay, that is 0.2 divided by, what is the measured value of breadth? That is 2.4 plus or minus, right? Right, it is not plus or minus, we are writing this plus. Relative errors are added. So delta L, how much is the length error? It is 0.1. What is the actual measured value? It is 5.7. That is equal to delta A by AM. There is a measured value of what? Area. You have just found the measured value of area. So that is delta A is equal to this AM goes over here. So it will be 13.68 whole into 0.2 divided by 2.4 plus 0.1 divided by 5.7. This calculation, please do it by yourself, guys. You will get a round value as 1.4. 1.39 something. I'm just round it off to 1.4. Right? So now I'm going to substitute these values into, this is the actual answer you require. That is A is equal to measured value of area plus its error, plus or minus its error. So A, area is equal to, what is the measured value? 13.68 plus or minus, what is the error? 1.4 meter square. That is the area. Clear? Now I think we can stop here. There is a section called division also, but I think that time will be consumed more, so I'm going to stop it here, guys. Please look into this section. It's very tough because for the first time in your lesson you are not going to understand it. Take your time and understand. Okay guys, bye.